YouTube? It's your boy JOSHABRAHAM, innit? It's a Josh Abraham, innit? It's a Josh Abraham, innit? It's Josh Abraham, innit? We got a lot of names. And today is as always, what was it? Thermodynamics. Thermodynamics. Say it with me. Thermodynamics. 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 Chemical thermodynamics. Oh, chemical thermodynamics. Oh. Actually, I was doing it on the browser ChatGPT. So wait. Don't look into it too much. It's a lot of bullshit, but fast oats eating tips. Hell yeah. Oats coffee drink idea. Well, you gotta do what you gotta do. So, the city shambles the world. I forgot the question number 17. Perfect. Now I see the confusion coming from. Let's carefully walk through the sequence you just described. The sequence of the line crossing you mentioned. First, gas liquid interaction, yeah. Then, solid gas interaction. Finally, that's a hypothetical interaction, so it's not gonna work out. How to interpret this? Remember, phase stability is only decided by the lowest Gibbs free energy line at each t. What? So the order of crossing is not as important as which line is actually lowest after each crossing. At the low temperature, lowest is solid is the lowest G. Yeah. When liquid gas line cross, both are still above the solid line, so neither becomes stable. This crossing has no physical consequence. Then, when gas line crosses with the solid line, now the gas becomes lower in G than solid. Okay, so gas transition, sublimation, so solid to gas. Okay, okay. Starting to make a little bit of the sense. Not the spotlight. Is this 172? Oh yeah, it's 172. My bad. I still haven't made the video I want to make about the whole new stuff happened to me. No, this one should go. And this belongs to the daily study stream. Yep. Well, it's unfortunate. So, after a particular amount of temperature, the gas crosses with the solid. So, solid changes to gas sublimation. Sublimation? Sublimation, not sublimination. It's just sublimation. What this means together? Gas and solid mathematically, but it never becomes. Okay, so this system shows a liquid gas phase transition. Liquid gas. Nope. No liquid gas phase transition. This system shows a solid liquid phase transition. Nope. Okay, D is correct. The liquid is not stable at any temperature. I think E is also correct. I want the answers right now. B is correct. No liquid gas phase transition. D was correct. No solid liquid phase transition. The liquid is not stable. Okay, so if there was an option saying if there was an option solid ah. Now we reach the calculation question. Stoichiometrically balance and calculate the delta H for the following reactions. I know how to approach this, but it's why should I waste time thinking if I can get a proper answer first? So 370 is what DeepSeek is saying. Mm-hmm. What are these songs, bro? Dude, it's so fucking good now. Yeah, I gotta do it on my own. Ah, baby, 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 baby. I Gotta charge this. Yep. Looks like I gotta charge my tablet. So hurry, start. Balance equation number 4. Yeah. If not balanced, okay. But this doesn't produce NO2. The intended reaction is likely. Fucking hell. Combine to get the target, the combustion. The formation reaction is the reverse of combustion plus the formation reaction of combustion products. 3 times 5 by 2 times to form nitroglycine. Where is nitroglycine? Okay. We can take its combustion products, convert them back to its elements, which is then form the elements into components. A lot of useless words. Restarting the problem with linear algebra form. Heist law. Each reaction is a linear combination of chemical species. Let the complete list of distinct species appearing in my equation. For each reaction, construct a stoichiometric vector. Dude, you gotta go that far? Whose jth component is the stoichiometric coefficient of species, taking reactants as negative and product as positive. Similarly, form target reaction vector VTGT. VTGT. The aim finds scalars. Dude, you're making this so, how do you say? Not complex. You're explaining too much. How to build a stoichiometric matrix and solve the subspecies S1. Okay, let me just try. Probieren wir. You also need to stoichiometrically balance equation number 4. So it's nitroglycine. Nitroglycerin. No, C3H5. It's 09. But this is 06. You kidding me? Yeah, it's 6. The fuck? You start with 9? Well, there we go. So, fourth reaction, C3, H5, plus O2 gives CO2, H2O, and delta. Mm-hmm. 6 plus. Dude, you're still going on. My god. 6 plus 2, 8. 2. Oh, 4. Okay, okay. 4. 2, 12. 12 plus 2, 14. That's 1 for sure. How do you get 5 by 2? Okay, whatever. 6. Oh. 3. 6. 12. 12 plus 6. 29 by 2. Yeah, 29 by 2. Mm, 29 minus 12. 17 by 2, right? Oh, 17 by 4. What the fuck are these numbers? Yeah, for real? For real? Think that's the number. For me, I got the. Again, how is it nitroglycine? Wait, wait, wait. Yeah, 17 by 4. Yeah. Mhm. I just got the first equation. That's it. Fourth equation is 1540. So that's it for this. Now, how do you balance the others? Oh, the others are balanced. Mhm. If you reverse the equation and substitute whatever is here. Okay. When I reverse the equation, will be and we won nitrogen. Wait. So we want nitrogen gas and stuff. So let's write those equations reversed. Equation number 1 reversed, half of N2 plus O2 gives NO2 gas. We're gonna replace that by 3 times. Second equation reversed. Do we have to write it reverse? Reverse. 34 kilojoules. Now 5 by 2. Minus 242 kilojoules per mole into 5 by 2. No, that's not reversed. Carbon solid plus oxygen gas gives carbon dioxide. And how much carbon dioxide into 3? Minus 394 kilojoule per mole into 3. Okay. Now if you substitute these values onto the equation, what do you get? 3 by 2 N2 gas plus 3O2 plus 5 by 2 H2 plus 5 by 4 O2 plus 3 CS plus 3 O2 giving 17 by 4 O2 plus C3H5 N3O6. Add the oxygens. 3 plus 5 by 4 plus 3 and 6. 29 by 4. Mm-hmm. 17 by 4 plus 6. 6 plus 24. Oh, shit. Mm-hmm. $602. There's oxygen? Okay, there's oxygen on the left side. Aha. forgot. How do you get rid of the oxygen? I don't need to get rid of them. It's just... So it's 29, yeah? 6 first to 24. Yeah, 29 by 4. 17. 29. How much is the difference? 10. 17 plus 10, 27. 12. 12 by 4. 12 by 4 is 3. 3 times O2. Okay. 3 times O2. Okay, I got it. Gives... Was I right? Was it right? Was bad? Okay, that was 5 by 2 H2. 3A2 N2. Okay. And next is the Heist law, but I know what it's gonna be. Product minus whoa, I don't know Heist law. Yeah. Yeah. Minus 6 of 5. Yeah. Now add all these steps together. Now to just add. Calculator. Clonopin Commander. Hey, how's it going? Oh shit, it's going okay, I would say. I mean, I lost my job, which would be the highlight for me for a couple of days. It's gonna be the highlight. But yeah, other than that, it's going pretty good. How about you? How you doing? Really appreciate for checking out the stream. 1540 plus 3 times 34. Doing okay. It's good to hear. Right now, I am preparing for the Chemical Thermodynamics exam, which will be coming up on Wednesday, if I am right. Let me just confirm it's on Wednesday, because I can't afford to lose. Exam timetable, yeah, 10th of September. That should be 8, tomorrow's 9, yeah, Wednesday. Then 19th. At least I don't have work, so I could make use of the time I have. That's amazing. Like, if I had work right now, I would have been like, oh, within 10 minutes I have to head to work. But now, I don't care. I don't have work. Can just study. I wish I just need to focus more. So, do you have work today? How was your day? If I remember, the last time you told me you were in vacation. 242, 242, 242 into 5 divided by 2. 605 minus 605. 394 into 3 minus 394 into 3. 1182. Yeah, I have work today. Okay, so I'm guessing you got back after the vacation. Well, time goes fast, eh? Does. And I don't know if you noticed the Twitch title. It's Crackathon. Well, I just I just decided to let the stream run all time. Let's see when is this laptop gonna crash. How. So 1540 plus 102 equals 1642 minus 1182 plus 605. So the answer is minus 145 kilojoules per mole. Please be right. Oh, hail to the year. But can I trust the deep seek? Okay, that's correct. So the last question. Well, Clonopin Commander, I have a question for you. If I don't know if you're here, but I guess you left. Yeah, I'll ask when you're here next time. Be right back. Oh, okay. Let me know when you're here. So in a bomb calorimeter with calibration constant C equals 2.75 kilojoules per Kelvin. 625 milligrams of naphthalene were burst, which caused the temperature increase delta T equals 9.18 Kelvin. Formulate the stoichiometrically correct chemical reaction. 625 milligrams of naphthalene were burned, which caused the temperature increase. Formulate stoichiometrically correct chemical reaction equation of the process described and calculate the molar enthalpy of combustion. I mean, combustion of naphthalene. What would combustion usually results in carbon dioxide and water? Oh well, there is gonna be oxygen involved. You can balance the equation. What else? What else? Data and molar mass, calibration constant, moles burned, 625 milligrams by molar mass. Okay, that's the number of moles. Heat released by the sample is calibration constant times change in temperature. Now, this equals the heat released by combustion, so. And we are talking kilojoules up here. No, I was playing music from the. Where is it? Where's the album? Yeah, we got it. Molar enthalpy of combustion. Calculate the molar enthalpy of combustion. So energy released by number of moles, reporting with appropriate. Okay. Okay, I need to know about this part. What? Yeah. Oh. What? What just happened? Ah. No, that. So, I'm wondering, how are the units handled here? Good question. Oh, every question is a good question. This means kilojoule. Kilojoule times Kelvin. So it doesn't matter. Okay. Did I accidentally send the wrong video? Oh shit. Okay, no. Okay. Let me solve it on my own. 18th, 19th question. Vado. In the bone calorimeter with the calibration constant. Calibration constant. C equals 2.75 kilojoules per Kelvin. I'm back. What was the question? Oh. Oh yeah, the question was right now I would be a first year student studying, like in one first year undergraduate. And how realistic would it be if I want to get a job into like part-time job, not even a full-time, just a part-time job into like bioinformatics sector? Like how realistic would I be if I started looking for jobs? Because I seen a lot of stuff, like a lot of people are like it's not even possible, and some people are like yeah, with the right sort of knowledge you could land a job. I don't know, it's so weird. It's it's probably easier to contact one of your bioinformatics professors and ask them if you can work for them. Okay, because from this October onwards, I am gonna be starting with my classes, and I do have some courses on bioinformatics. So yeah, I will be talking with some of the professors on this course, cause yeah, I don't feel good working something else. If I'm working, I gotta be doing something that helps me to understand how this sector works, how this field works. So, yeah, I need to look into those seriously. But first, I gotta complete the GROMAC. I still haven't completed the introduction part, and I gotta show you this. Oh wait, look at all the files I got just from GROMAC. What the fuck? That's a lot of files. That's a lot of files. I didn't. Oh wait, I did not expect this to make this much files. You can delete the ones with hashtag before them since they are just backups. Okay. I also need to make a new folder where it saves all the files, because right now it's all going into downloads, and I don't want a lot of files on downloads because you can't pinpoint. After completing the first the lysome in water simulation, I will make a new separate folder for all the GROMAC files. Make it small, yeah. 1, 2. And how does it react? In understanding the map. Fucking app. What was that? Oh shit, that was so weird. Well, I'll edit it later. Oh, how did I solve this? Calibration constant, mass of naphthalene undergo combustion equals 625 milligrams. I mean, would that be a question? Like, if I get a job or if I do something based on bioinformatics and I stream whatever I'm doing, would that get me in trouble? I mean, no, because I am literally working. That's not like against the policy or something. I don't think so. Depends if it's proprietary. Okay. Yeah, some some sort of data would be like, oh, you can't release this onto the public. But yeah. Yeah, it depends. C10H8. That's the naphthalene. If I remember naphthalene, those are used to kill cockroaches. And the change in temperature after combustion, 9.18 Kelvin. You might also want to get familiar with Python, in particular the scanpy package. Okay, scanpy. I looked into Python, like there was a CS50 Harvard class was 9 classes, 1 hour each. I wouldn't say I'm a good at Python, really beginner, but ScanPy. The only other package of Python I heard was BioPython. I did download those, but ScanPy, I never heard of it. Like, would that be used for scanning data? I mean, the name says ScanPy. For RNA sequence data mining. Okay. Okay. ScanPy. Beep, beep, beep. Could you explain more on ScanPy package Python? Single cell gene expression. Okay, I really thought everything that's related to biology and Python would be in BioPython. Guess I was wrong. I was wrong big time. Hmm. Well, I should say let this chat exist. I need to dig deeper on that part. That will land you a job. That will help you land a job. Sorry, I also get familiar with terminal bash slash ZSH. Terminal, like this guy. That was fast. That was fast. I actually spent the one whole day just to get this spotlight working, and it works amazing. Terminal bash slash ZSH. That would be like basic terminal, like, you know, I can literally see my limitations. What is this part of my Mac OS? Mm-hmm. Shell programs. Mm, nope. Where's GPT? Born again shell. ZSH shell. Auto completion and suggestions. Start typing a command and it suggests the rest. Allowing improvements, better pattern matching or for files. Prompt customization. Very easy to make fancy prompts. In short, terminal is the app. Is it a ZSH bash? Are shells running inside it? Terminal is like window. Shell is the brain behind your commands. Okay. Interesting. What is this guy talking now? Do we have any sort of? Oh, there's ZSH. Those hints give the molar masses of the elements, so you can calculate the molar mass of naphthalene, which you need to find the number of moles burned. Let me break it down. Naphthalene formula: C10H8. Molar mass calculation. This would be molar weight. Oh, it's molar mass. Okay, I'm too stupid. Like an idiot. So, how we calculate from? I believe milligrams are 10 raised to minus 3 of 1 gram. Right. Milligram is 10 raised. So here's the list. A. Python, ScanPy, BioPython. B. Bash/Zesh. C. Machine learning. These need to be on your resume. CV, yeah. Machine learning techniques, PyTorch, TensorFlow, statistics in general, could use Excel. You know what? I'ma copy that. I'm just gonna copy that and paste it on my notes if you don't mind. Stuff that should be in my resume. That should be there. Yep, no problem. I really appreciate the help because I don't know, maybe it's a beginner problem because I never heard of any of these. And every day I'm learning new stuff. Every day something new is always coming up. I really appreciate this help because this should always look out for each other. Wait, what's your undergraduate degree in? Yeah, it would be biological chemistry. Biologische Chemie. So biochemistry in short. I would say that. And my course is actually it's distributed in a different way. I don't know if you could see it, but yeah. So I wouldn't say completed the first two semesters, but I'm getting there. Nice, I have that as my undergraduate degree too. Oh, you started with this course. What would you? What's your opinion on this? Do you think it was it gets it, do you think it gives you enough knowledge to think more onto this field, onto these different subjects like chemistry, biology? Yeah, those are the two subjects. And what I was saying was my like next month I should be heading to another university as part of my biology program. But right now I don't have any source of income, so I'm going to skip that university. That means I'm going to skip the biology part for this year. I'm going to do it last year. I don't know if you understood, but yeah, third and fourth semester I'm going to do it later. And this was the part informatics, sequence analysis and phylogenetics, introductions to machine learning, introductions to AI. And then there's biophysics. I don't even know what that is. Well, I gotta learn everything out here. Everything. Not even a single subject get. Not even a single subject would be out of my sight. T delta T 9.18K. And was that right? Milligrams equals gram into thousand. Oh, okay. Milligram to gram. Divide by thousand, yep. So milligrams to gram equals 6 0.625 grams. That's the mass. Now molar mass. God damn, the molar mass is gonna be a really big number. Because we got 10 carbon dioxide. These courses will prepare you for a master's slash PhD, but not a job. If you want a job, you will have to start doing research for a professor in addition to your coursework. Okay. These courses are not job focused. They're more like more content, knowledge type. But yeah, if you want to, that's a really weird, interesting emoji. Okay. I really need to talk to my professors. I don't talk too much. I think in my university only two professors know my name. Like only two of them actually noticed. Yeah, there's a guy called Josh Abraham. He's there. The other professors don't even know. So yeah, I need to talk more with the informatics sector professors and the research. Did you do any sort of like helping your professor during research? Have you tried doing that? 12 into 10. When I was when I was in undergrad, I did bench work like culturing cells, etc. Oh, okay. I mean, that would be like a job that requires experience, right? Yeah. Bench work. That's probably not what you would want to do. You want bioinformatics professor. I mean, mm-hmm. So you actually worked in a wet lab as part of during your undergrad. Mm-hmm. Culturing cells. Yep, wet lab before dry lab. But my thinking was first I get into dry lab, then into wet lab. That was like yeah. Basically, I want to know what each site does, wet lab and dry lab. So my understanding right now is dry lab helps in huge amount of data, stuff like those. Well, wet lab helps in how do you say wet lab? Wet lab helps in real simulations because if you try to simulate what you can do in a wet lab, the computer is gonna blow up. So yeah, that's what I felt. At least for now, I felt like wet lab and dry labs differences are really specific. I don't. Yeah, dry lab is more math. Wet lab would be more onto the field. Well, I would like to explore both of those, and I don't know if I'm being realistic, but dry lab first is taking the dry lab first the harder route, or is taking the wet lab the harder route? And harder is such a I wouldn't say hard like which which path needs more experience or easier to get a job? I think from your experience, do you think wet lab is more easier to get a job? And job as in I'm only talking about part time. That's more I'm looking for, but this is the moment. 10 times C, 12, 120 plus 120 plus H 8 times plus so 128 grams per mole. That's the molar mass. And oh, I forgot to write the equation. Hmm. No, it's still not showing up as I want it to be. Mm, yeah, combustion of naphthalene C10 H8 plus O2 gives CO2 plus H2O. And how are the numbers arranged? C10 We need 10 carbon dioxide on the other side. So that's gonna be 10. Now we have 20 oxygen on this side. We got 24 oxygen on the right side, and it's really easy. Just put a 12 up here. I believe that's the answer. That's that's the balanced equation. You did not even write the balance. Do you need the balanced equation? Oh, you don't even need the balanced equation. Wet lab and dry lab don't have to be separate, but often are because of time constraints. Not sure if there are any part-time jobs for this type of thing, honestly. People want your full attention to their research. Okay, yeah, I get that. Mm-mm. Yeah, wet lab, dry lab, both are two sides of the same coin. We could say that. But yeah, I really want to explore both sides. I want to see the limitation of both these sides. When does wet lab be like, nah, that's not possible, and when does dry lab be like, only wet lab is good for that? No, she want to observe the limitations. But yeah, I want to look into more. I want to intern into more of other people's research, just so I could know, yeah, how are they doing it. That would be the route I should take. So I didn't need to write the balance equation, but I did it anyway. And number of moles of ethylene equals 0.625 by 128. 4.88. 4.88 into 10 raised to minus 3. I'm also living nearby the university. I should look it up. Mm-hmm. Now, number of moles into energy released. What was the thing used for calibration constant? Calibration constant. Multiply calibration constant by delta t. What is this? Uh, what are we? What is this formula results in? What does this formula? Okay. QCAL. Okay, energy released. That would be okay. Energy released. QCAL equals calibration C multiplied by delta T, which is 2.75 into 9.18. 25.245 kilojoules. Now, what should I find? Calculate the molar enthalpy of combustion. Oh, we calculated the heat released. Molar enthalpy of combustion is heat released by number of moles. Okay. Molar enthalpy of combustion, heat released by number of moles, or calibration constant into change in temperature by number of moles. That's also correct way to solve it. And we get how much we get? 25.245 divided by 4.88 into 10 raised to minus 3 divided by 4.88. 5.173. We get the 5 above, and it's gonna be 5,000. That's too big. No, you don't think that? So I got the molar enthalpy about 5,173 kilojoules. It's a big number. So what does this 5K say? I didn't really understand what this value is. Kilojoules per mole. Okay, so per each mole, that much kilojoule is released. It's the amount of release when 1 mole of naphthalene is completely burned in oxygen to form carbon dioxide. The negative sign. Okay, so for petrol, diesel, these molar enthalpy enthalpy would be really high. Much higher in fact, much higher on a per mole basis than for a small molecule like naphthalene. Hydrocarbon fuels, petrol, gas, roughly okay. Diesel, okay. Their molar masses are higher than naphthalene. Combustion enthalpy. So denser the molecule, more energy they could release. Yep, I understand. I understand. Now, what is the last question? How does the boiling point of water change when you move? Energy released when 1 mole of naphthalene is combusted. How does the boiling point of water change when you move from North Sea to Puslingberg? I know that place. It's sufficient to state the change qualitatively. Qualitatively, why does this mean for vapor pressure? What is the name of equation that describes this relationship? It is sufficient to state the change qualitatively. What does this mean for vapor pressure? What is the name of the equation? Oh shit, you know the answer. The boiling point decreases because less than 1 atmospheric pressure in the environment. Ah, decrease in pressure results in decrease in boiling point. Mm-hmm. So from North Sea to Puslingberg, where we would be getting more pressure, like the boiling point with elevation pressure decreases. Yeah, I believe elevation results in decrease in pressure. Let me. This elevation results in yeah. Okay, so there's a decrease in boiling point. I appreciate that. You know, when you start remembering stuff like elevation, increase in elevation results in decrease in pressure, which results in decrease in boiling point. When you try to memorize like that, it's gonna help me in the examination. Now, what is the equation that describes this relationship? Is it the ideal gas law? Mm, no. Oh, it's the Clapeyron equation. Clapeyron. Clapeyron. I remember doing a presentation on this equation and what did I say? By using the Clausius-Clapeyron. Yeah, that's what I said. I believe that was the right wording. Effects of altitude on boiling point. Okay, pressure decreases. Implication for vapor pressure. At lower boiling point waters, vapor pressure reaches. At lower boiling point, that means at higher places, water's vapor pressure reaches the ambient pressure sooner. So vapor pressure at the new boiling point equals the lower atmospheric pressure at lower atmospheric pressure, lower boiling point temperature. Vapor pressure equals ambient at lower temperature. Equation describing the relationship. The Clapeyron equation, so its approximate form, the Clausius-Clapeyron, describes how vapor pressure changes with temperature. Do we have vapor? What does this mean for vapor pressure? Okay. If I remember vapor pressure, it is the pressure. It is the pressure released by a liquid inside a closed system when it's in its equilibrium. Vapor pressure is the pressure of the evaporating material. Okay. Yeah, it's if I the last time I checked it was, yeah, the pressure exerted by the liquid inside a closed container. That was like the common form of description. Yep. Okay. And higher the place, the vapor pressure also increases, resulting in lower boiling point. Yeah, and vapor pressure at some point in the elevation is gonna be equals the ambient pressure. I what is this ambient pressure? Is it normal? Are we talking about atmospheric pressure? What's the ambient pressure we're talking about? Oh, that's an important point. In this context, ambient pressure just means external pressure surrounding the liquid. Oh, okay. I thought it was atmospheric pressure at the zero or something, which is usually atmospheric pressure at the location. Okay. Okay, it's not like atmospheric pressure at the sea level. It's atmospheric pressure at that location. So higher the position, lower the boiling point, lower the pressure, higher the vapor pressure, and at some point the vapor pressure is going to be equal to the external pressure. Do we have a name for such situations? What is the name of the question? Okay, I don't think we have a name for. Is there a name for the situation when vapor pressure is equal to the ambient pressure? Equilibrium. Okay. Okay, we just came full circle. Okay, yes, the situation is exactly what defines boiling. Okay. Boiling point is the temperature at which vapor pressure equals the liquid start to boil, forming vapor bubbles throughout the bulk of the liquid. Tied to the equilibrium condition. Interesting, it's these things just act on their own. They make their own rules and just act. Yeah. Yes, they do what they want. Ah. They don't care what's happening around the world. I don't get it. How is this calculation question? Okay. That emoji is interesting use of emoji. Twitch global emote LUL. Okay. I thought I saw this person somewhere. Well, higher the elevation, higher the boiling point, lower the pressure, higher the wall vapor pressure, and when the vapor pressure is equals vapor pressure equals the ambient pressure, it could start boiling. Boiling point is the temperature at which vapor pressure of the liquid equals ambient. As the fundamental levels, though, no one understands what's really happening. These equations are only quantify macroscopic behavior. Yeah, I mean, the deeper you go, the weirder these stuff acts and performs. I mean, we can, from what I heard, we cannot pinpoint an electron. That thing just, it's just somewhere. So yeah, at the very end, it's just you can't point at this. Yes, you cannot know its momentum and position at the same time. Yeah, it's like no, it's forbidden. It's forbidden. It's weird. So what was I thinking? No, vapor pressure equals ambient pressure, liquid starts to boil. So how is the temperature gonna be in this situation? Are you going to take physical chemistry 2? Uh, what would be that? What is physical chemistry? Because in my curriculum, oh wait, let me pull that up. For me, it would be in the position of, oh, I do have, okay. Okay, we have physical chemistry. I'm seeing that first time. Okay. Is there physical chemistry too? Oh, but for me, it's a lab course. Physical chemistry for biological chemistry. Uh-huh. And okay, the what you meant by physical chemistry, the higher form of physical chemistry, I'm thinking it's like you said, it's quantum mechanics. Do I wanna explore? Yeah, I really wanna explore how quantum mechanics, the whole thing. I heard it's like forbidden knowledge. I once saw a video where a professor was like, we're gonna learn quantum mechanics. At the beginning of this lecture, I am the only one who doesn't understand what's going on. But the end of this lecture, we all don't understand what's going on. Now that's a subject you want to learn. Quantum mechanics. Did you do any courses or have you looked into quantum mechanics? Well, I don't have quantum mechanics. Temperature of the liquid in this situation is boiling point at specific ambient pressure. Boiling point at. Yes, I took quantum mechanics in undergrad, then two in grad school. Ah. What would you say, quantum mechanics? Is it like fucked up? Uh, some of the things I know about quantum mechanics was string theory. String theory, what else? Wormhole. I think those are part of quantum mechanics, would be. Uh, there are like 10 postulates that are stated without proof, and then all calculations are based on these postulates. Mm-hmm. So it's like they just imagine how this works, and oh wait, I'm getting a call. I'll be right back. It's my family. Just a minute. Yup, we are back as ever. Well, I was talking to my parents, not just parents, my whole family, so that's why I was taking some time. Let's go. Oh, you're still here. Appreciate that. What was my question? Temperature. The temperature of the liquid in this situation is the boiling point at specific ambient pressure. Temperature of the liquid is in this situation is the boiling point at specific ambient pressure. Uh-huh. Okay, it's the same temperature as boiling point during that pressure. Vapor pressure of the liquid increases with temperature. Okay. At some temperatures, the vapor pressure equals the ambient pressure. Okay. And TB is the boiling temperature of that pressure. Okay. I think I got I got somewhat understanding. I would say vapor pressure, temperature. What was the third factor? Ambient pressure and elevation. Well, that's the first question paper. I would say I did a little bit. I will do it at the end. Now we are gonna start. Actually, I think I did my chemistry for a while. I think I should start with the biocoding. Because, I need to do GrowMac every day. Let me see how long I did this. Two hours, yep. I'm gonna switch the gears. How do I switch the gears? Yep. End to the YouTube stream. YouTube, peace out. I'm gonna be starting with the biocoding.